Alrighty, in this lecture, we're going to be learning about lesson 4.4, which is inverse functions or inverses of functions. I'm going to kind of jump right into the different examples, and then with those examples, kind of discuss some things. So I'm going to first look at number 2, which basically says that S is equal to the set of coordinates of -3, -3, -1, -1, 0, 1, and 4, 4. All right, so this right here is what we call a relation. Not necessarily, it could be a function as well. Remember, to have a function, we don't want our x's to repeat. So this one happens to also be a function. But to have an inverse doesn't necessarily have to have be a function. A relation doesn't necessarily have to be a function to have an inverse. That inverse might not be the inverse might not be a function itself. And we'll talk about that as we go on. But the big thing here, basically for inverses, so a little note here, if R, whatever set that is a relation and contains points as like x comma y, then the inverse, which will be noted with a little -1, will contain points in which we switch the y and the x or switch the domain and the range. So in question 1, it's asking you to graph the inverse of the following relation and then state the domain and range. So what I'm going to do is I'm going to go ahead and find the inverse set, and I'm literally just going to switch all these. Now, this is probably not the best example in the book, but it was kind of similar to what I saw in your notes. You want to, or in your homework, sorry, you want to switch the x and the y, but you'll see that not much changes until we get to this third point, which will now become 1, 0. And so when you state the domain and it's as a coordinate, you write it with a set bracket here and you list from least to greatest. So that would be -3, -1, 1, 4. You don't repeat any numbers either. So this is again be -3, -1, 0, 4. So this will be the new domain and range. And of course, to graph it, you would just graph the coordinates. So that would be coordinate about right here, about right here, about right here, about right here. And that's all that you're asked to do on those first couple of questions. So let me do another one that's in a function way. So let's say y equals the absolute value of x plus 2. Alrighty. So at first, it's going to kind of, well, we'll just kind of go how they want you to do it. Uh, you can do this in one of two ways. And I think the way they want us to do it at first is if you just produce a domain and range. Well, we'll do it this way. Produce the domain and range of this function. So if you need to graph this function, remember this is the absolute value. So it's going to make the v, and this plus 2 is going to shift it up. So I'm going to go up 2, and then there is my original function. So when we talk about the domain, it looks like it's going to be all real numbers. And then my range looks like it goes from, again, bottom to top, from 2 to infinity. So when we talk about the y inverse, the domain and range of this guy doesn't ask us to go find the inverse yet. So I don't want to get too far ahead on a question that's pretty easy on the homework. But all we have to do is switch the domain and range. So my domain will now be 2 to infinity, and my range will now be all real numbers. So to graph this, you can just kind of take points from this original graph and switch them. So this right here would be 0, 2. So I'm now going to switch that. So I'm now going to go 2, 0, which will be right here. Then you could choose another point. Because it's just the absolute value of x, there's no stretching or compression. The next point could technically be right here, which would be 1, 3. So I'd switch that and make it 3, 1. So again, this is now 2, 0. This is now 1 or 3, 1. Again, switching the x and the y. I can do the same thing over here. I can go -1, 3. So again, this right here would be -1, 3, and then switch it and go 3, -1. And you could keep pulling stuff like that until you kind of realize that your graph is going to look like that. Basically switching the domain and range. And that's all that you're asked to do that. You're not asked to go actually find the equation yet. So hopefully that kind of clears up those couple of questions you get at the beginning of your homework. I thought were kind of interesting because it kind of doesn't go with the book in my opinion. Oh, and sorry, that was number, let's see, I have reference. I believe that was number 4. All right, so now we're going to jump to number 25. And then on this type of question, it's telling you, again, you're given f of x equals x squared minus 4x. It says determine if the following function has an inverse function. If not, suggest a domain to restrict the function so that it would have an inverse. And the answers could vary depending on what you choose. All right, basically what we're going to do is we're going to graph this first. Remember, this is a parent function of a quadratic. Ooh, actually, not quite because of this. I wonder if they want you to graph it first. All right, I'm gonna have to. Ooh, is it only this function type? It is kind of this function type that you see on the homework. Okay, so this is a quadratic, but this right here kind of leads in a different direction on how you would graph it versus what we've seen in our normal parent function. You would typically have to write this into vector form to get it that way. But to save ourselves some time, what we're going to do is I'm just going to factor. So I'll pull out an x right here. And then when I set these x is equal to 0, these represent my x-intercepts. So when I'm graphing them, I will then get a point at 0 and at 4. And then if I want to find the vector, I can again use my formula from an earlier chapter of -b divided by 2a. So this gives me -4 divided by 2 times 1. So that's going to give me a +4/2, which is just 2. Back substitute that in. So f of 2 would be 2 squared minus 4 times 2, which gives you 4 minus 8, which gives you -4. So my vertex, not vector, sorry, vertex would be 2, -4. So I'm going to go 1, 2, 1, 2, 3, 4. And so then I can do this. All right, so this is a lot easier than trying to put it in vector form, in my opinion. All right, so to determine if a function's inverse is a function, this is what they call the horizontal line test. So you recall that a vertical line test tells you if it is a function. So we did this earlier in a different section, but if I was to build straight lines to this and it only crosses one time, it's a function. For the horizontal line test, am I able to draw lines in which it only crosses once horizontally? In this case, no. So therefore, their inverse function well, I guess in this case, there is no inverse function. This should be a comma maybe. Right, because it fails the horizontal line test. Now, there is a way that what we can do is make this have a function, and that is if we split the quadratic in half and give it a restriction. And we say, all right, if f of x equals x squared minus 4x for only x greater than or equal to, what's that, 2, and I just do that restriction, then I would only have this function graphed and it would pass the horizontal line test. So your restriction there, it could, if restricted to x greater than or equal to 2. I don't remember if it has interval as an answer, but if it does, it'd just be 2 to infinity. Now, it could be alternatively, you could be like, well, can I go a different direction? You could. It could be everything less than 2. So I could just simply graph this side of the function and it would also pass, but I cannot go anywhere else. So if I was to go here, it would fail. So it's either going to be this one or this one. All right, so you go the left side or the right side of the graph. And of course, if you went with this direction, it would be negative infinity 2, 2. All right, so just because it doesn't have a function, we can restrict the domain, and therefore the inverse could be graphed. And we'll look at some of those here in a second. All right, let's look at the next one. So we'll look at number 29. All right, sorry about that. All right, so on number 29, we have f of x equals x to the third or 1/3 minus 2. And we are asked here to find a formula for the inverse of each of the following functions. If necessary, first restrict the domain of the function. So what that means is graph the original function. So what we need to do is write this in a notation that you're more familiar with. Anytime you see like a fraction here, recall that like 1/2 is the same thing as square root of x. 1/3 is the same thing as the cube root of x. 1/4 is the same thing as the fourth root of x, just like we did in one of our other videos. So if I rewrote this as the cube root of x minus 2, you might see that the parent function is the one that, let's do that a little bit, is the one that looks a little bit like this right here. And then the -2 is just going to shift it down. So my function here would be like, in the best sense. But then when you did a horizontal line test, it does pass. It does looks like it's plateauing there, but it does pass. It never hits more than once. So we don't have to worry about restrictions. Once you determine that there's no restrictions needed, it's a 3-step process. Step 1, we're going to change f of x to y and switch x and y. So what I mean by that is I'm going to change f of x to a y, and then I have the cube root of x minus 2, and then I'm going to switch the x and the y. So then this becomes x cube root of y minus 2. All right. After that, step 2 is to solve for y. All right, so to do that, I'm going to add 2. That gives me x plus 2 equals the cube root of y. And then the inverse of cube rooting is cubing. So now I'm going to cube x plus 2 cubed. And then you can keep it like that. You don't actually have to FOIL that out. And then the third and final step is to change y into f of -1 over x. All right, so I'm just going to change this y. So it now becomes f -1 x. I told you earlier that -1 indicates inverse of x plus 2 cubed. Now you found an inverse. And you're not asked to find the domain range. That is pretty much all you're asked to do. All right, so let's do quite a bit more of those. You have more of those on the homework. So let's look at 31. We have r of x equals x minus 1, 3x plus 2. On number 31, sorry, on 31, we have a function here, a function here. This is not a normal parent function. Believe though, might need a calculator for this one to justify your answer. But I'm almost positive this is one with branches. So this is going to be like, can't be -2/3. So there's going to be like a vertical asymptote there. And then there's probably like a horizontal asymptote about right there. If I plug in, let's go with 1. I get 0. So 0 would be like right here. So I'll have a branch kind of like this. And then if I plug in maybe a -2, I'll get a negative on top, negative on bottom. I'll probably have a branch like this, give or take. Well, actually, hold on. No, it'd be two negatives make a positive. So it's actually up here. So we can see that it would pass the horizontal line test, but you can use a calculator to justify that. And because it doesn't need a restrictions on the domain, I can go straight into my steps. So again, I'm going to change r of x to a y. And then I'm going to switch the x and the y. Now we're going to solve for y. First thing to do is we don't like fractions, so I'm going to multiply by the denominator on both sides. So I now get, I'll go ahead and distribute this. So this becomes 3xy. By the way, technically it doesn't matter what order you put your letters, but in math, grammar-wise, you want to go alphabetical order. So even though 3yx is the same thing as 3xy, do write it in alphabetical order. So we'll write it as 3xy plus 2x equals y minus 1. Once you have it in this form, you want to move all the y's to one side and all the non-y's to the other. So I'm going to subtract y, subtract y, subtract 2x, subtract 2x. All right, so this now becomes 3x y minus y. That will go away, that will go away, and then this becomes -1 minus 2x. You could write -2x minus 1 if you would like. That part doesn't matter. Now, once it's in this form, you're going to factor out a y. And when you do that, you now get 3x minus 1 equals -1 minus 2x. You'll then divide by that binomial. Then I get y equals -1 minus 2x over 3x minus 1. Then we're going to switch the y to an f -1 of x and then rewrite our answer. And there you go. All right. Let's do some more. So we're getting more comfortable with this. Let's look at number 33. This says f of x equals x minus 5 cubed plus 2. Again, hopefully you see that the parent function is a cube, so it looks like this. And then, of course, I just shift it right and up, so it still passed the horizontal line test, so I don't got to worry about any restrictions. So I can go straight into solving. So I'm going to change f of x to a y. X minus 5 cubed plus 2. Switch my x and my y. And then start solving. So I'm going to subtract 2. So I get x minus 2 equals y minus 5 cubed. And then to inverse of cubing is the cube root. It's slightly different from a square root. You do not need a plus or minus. So it would just be the cube root of x minus 2. And then I'm just going to add 5 on the outside of the function. So I get the cube root of x minus 2 plus 5 equals y. So technically, I guess I should put it here. This is when we start solving. And then I'm going to rewrite it with a f -1 of x, which again will be the cube root of x minus 2 plus 5. Alrighty. Let's keep trucking along. Let's look at number 35. This is going to be v of x equals x plus 5 over 2. This is technically just a linear function. You're just dividing by 2 and multiplying by 5. So a linear function looks like this. And no matter how I stretch it or move it up or down, it's still going to pass the horizontal line test. So I can go straight into solving. So then I switch the x and the y. And then I'm going to start solving. So I'll multiply by 2 first. So I get 2x equals y plus 5, and then I'll subtract 5. So I get 2x minus 5 equals y, and then I'll switch y into f -1 of x and rewrite my answer. There you go. So a linear function is pretty nice on finding the inverse. Another one I saw, let's look at number 39. So we get j of x equals 2 minus 1, 3x. This one we do have a parent function of, and its parent function is 1 over x. We know this one. Again, it's going to pass the horizontal line test, so I'm ready to just go ahead and start solving. So I get y equals 2 over 1 minus 3x. Switch my x and my y. And then just like last time, I'm going to multiply by the denominator. Oop. Did not switch the y. That will go away. I'm going to go ahead and distribute. That gets me -x minus 3xy equals 2. Again, I'm going to move everything that is a y to one side, everything that's non-y to the other. So really all I got to do is just add x. And then now I just got to divide everything that's next to the y because there's nothing really to factor there. So I get y equals 2 plus x over negative 3x. Don't worry about simplifying, just keep it like that. So I'm going to rewrite it as 2 plus x, or f to the negative 1, which represents the inverse of 2 plus x over negative 3x. All right, let's do a couple more in this type of pattern. So let's do number 46. So let's look at q of x equals x minus 2 squared plus 2. Again, this is a quadratic, so I know it's going to look something like this, and it's actually going to fail. So I'll show you how we can restrict this. So for now, we'll just keep it as our status quo here. Switch the x and the y. And then we'll start solving. So I'll start off by subtracting 2. And then I'll take the square root. But remember, when we take the square root of something, we have to have a plus or minus. So I get the plus or minus square root of x minus 2 equals y minus 2. And then I'll add 2 on the outside of that. So I get plus or minus the square root of x minus 2 plus 2 equals y. So what we can do is when we're trying to rewrite this, we'll write it as f negative 1 of x. I can't write two functions at the same time. So what I do is I'll start with the positive version, doesn't really matter, minus 2 plus 2. And then the domain here, since I'm doing the positive version, will be x is greater than or equal to. We need to determine our vertex. So our vertex here, change the sign as 2, because remember it's HK 2. So what we'll say is we just got to be looking at the x value. This will be x greater than 2 for this one. And then this would be x less than or equal to 2. So if we restrict our domain afterwards, then we can say, all right, this is the answer. If our restriction to this function is x is greater than or equal to 2, this is our answer if our restriction is x less than or equal to 2. So it's a lot easier in my opinion, but I guess we could have technically done it immediately right here once we found the vertex. I did have to go back, but then you still got to go find both answers. So I don't know, however you want it. You can do it at the beginning or the end, but let's do another one just so you have a good understanding of this. So let's look at 49. So this is f of x equals x plus 1 to the 4th power minus 2. Again, we have a situation where it's going to fail again, but again, you could do it at the same time or not. It's still h and k even for a quartic. So in this case, that's negative 1, negative 2. Remember, it's always the opposite sign of the h. So you can have your restrictions of x greater than or equal to negative 1 and x less than or equal to negative 1, but you still got to go find the equations that work for it. So however direction you want to go with that, we'll get to the same conclusion. So I get y equals x plus 1 to the 4th minus 2. I'll switch my x and my y. And then I'll solve. So I'm going to add 2. I get x plus 2 equals y plus 1 to the 4th power. The opposite operation of a 4th power is a 4th root. But because it's an even index, I have to have a plus or minus. So this becomes plus or minus the 4th root of x plus 2 equals y plus 1. I'll subtract 1 on the outside of the function. And then when I rewrite this, I'll write my two functions as the positive version. So this will be x is greater than or equal to negative 1. And then I'll write my negative version. And this will be x less than or equal to negative 1. Again, using that h value. Alrighty, so let's see. I think I only have a couple more. Yeah. So let's look at a couple other questions you'll be given, or really just one other question. We'll do two of them, but we'll look at number 50. So in this exercise, you just got to verify. So if two things do have a function, that would mean then that the inverse, well, the composite function of an inverse and its original function and the inverse of its original function, these two right here, will equal x. So that's what they kind of want you to do here. So just kind of prove both of them. So what you'll start with is f of x is equal to 3x minus 1 over f. And then it says that the inverse is 5x plus 1 over 3. So what we're going to do first is we're going to take this function and replace the x. So f of f inverse of x. We're going to take that, plug it in. So that's going to be 3 parentheses 5x plus 1 over 3 minus 1 over 5. So I just replaced the x with that function. Now we're going to simplify. The 3's cancel. So I have 5x plus 1 minus 1 over 5. The 1's cancel. I get 5x over 5. The 5's cancel, so I get x. So the first part worked. So now we're going to do the other direction. This time, I'm going to take this function and plug it in for this x. So this is now going to be 5 times 3x minus 1 over 5 plus 1 over 3. So the 5's would cancel. So you get 3x minus 1 plus 1 over 3. The 1's would cancel. So you get 3x over 3. And then here you go. So even though you could see it probably in your head, to prove something or to verify something, you got to show all the steps that got you to that point. So that is verified. So let's just do another one so you have clear understanding. This time I have f of x equals the cube root of x plus 2 minus 1. And the inverse is x plus 1 cubed minus 2. So again, we'll start off. It doesn't really matter which one you start off with, but I always like to plug the inverse in first. So again, I'm going to take this, replace this x. So this is going to become the cube root of x plus 1 cubed minus 2 plus 2. So this whole thing replaced that x, and then I still had a plus 2 and then a minus 1. So now when I'm working, I see the minus 2 and the plus 2 go away. So I have the cube root of x plus 1 cubed minus 1. The cube and the cube root will go away. So I now have x plus 1 minus 1. The 1's will go away. So now I have x. So then we'll verify the other one. So this time I'm going to take this entire function and plug it into this x. So this will give me the cube root of x plus 2 minus 1. So that I'll replace that plus 1 because there is that plus 1 there, cubed minus 2. So I see the 1's would cancel. So I now have the cube root of x plus 2 cubed minus 2. The cube root and the cube would cancel. So I now have x plus 2 minus 2. The 2's would cancel. So I now have x. So you did properly verify. That's pretty much everything that you'll see in the homework and pretty much what this section is. This is the last topic for your first test. I'll probably make another video, but just to give you a heads up, there will be a practice test that will appear on Friday. It is not a grade. I just want you to be exposed to what the test formatting is so you're not surprised on your first test. Do practice the test questions so that you're familiar with what's going to be over. I'll probably do a review over chapter 3 and 4 using that as a guide to help you prepare for your test. When we get to our test, it'll be open from Monday to Thursday. You'll have about 90 minutes to do it. So the moment you start, you got 90 minutes to finish it. So when you hit the start, make sure you're prepared for it. Make sure you have to show all of your work for each question, and then there'll be a spot in Blackboard for you to upload those. It is locked down browser, so you won't be able to access anything else other than your work. And then your work itself will tell me if I know that you know it. So I'll be able to identify if you found something online. pretty easily with this type of math. But if you have any questions about how the test is going to be working, let me know. I'll have that review video probably posted on Friday when the test releases as well, or the practice test releases. So you'll have, and it'll be open from Friday to the Thursday. So you'll be able to practice that over the weekend or into the week and then take your test. But the work also needs to be uploaded by that Thursday as well. All right. If you have any questions again, feel free to reach out. If you need more any examples, let me know. Until the next video.